Hey, ladies and gentlemen, today we're going to learn about how to write an exponential regression model given a table. So already in our course, we have done linear regression models and we've done quadratic regression models. So an exponential regression model is actually very similar. It's just going to be substituting slightly different parameters into your equation of an exponential function. So I'm going to show you how to do it on Desmos for this video, and then I'm going to do a second video to show you how to use it, to do it using a TI 83 or 84. So this will be all Desmos. Then I will also do the TI 83, 84. To me, it kind of doesn't matter which way you do it, just as long as you get good with the way, and so that you would be able to do it on your own without any help from somebody else. So, and also linked to this video will be calculator directions on how to do it in Desmos and in the graphing calculator, like written out for you, so you don't have to constantly keep watching this video if you don't want to. So, okay, so first things first, with the Desmos, you want to go and hit the plus and then do a table. Now your X values will go underneath the X spot here in the table. Your Y values will go underneath the Y. So here underneath X, I've got 1, 2, 4. So 1, 2, 4, 5, and I think it was 6, 9. Yep, 6 and 9. I'm going to go ahead and put the Y values in. So I've got 2, 5, 10, 2, 5, 10. I think it was 15 and then 20, but I will double check that. 15, 20, yep. And then 38. The big thing is, like this topic isn't super hard, but it is, you do have to make sure that you are looking at your tables and typing it in carefully. Underneath there, you're going to get a second line up, and then you're going to type in our very generic, or our function, our exponential function. So I'm going to do y1, and if I hit y1 on my keyboard, it automatically subscripts it for me. And then I'm going to do my little similarity squiggle. On mine, it's just shift, and it's the button that's next to the 1 on my keyboard. If you were to need to use, you can use like your keypad here, and you can go to the ABC if you need to, and it's right there. But again, I'm using my regular keypad for this. And our function is going to be A times B. I'm going to raise this to the X1. And again, I just hit X1. Now in Desmos, you do need to select the log mode so that it gives you this, so that it gives you the same equation as if you were using a TI 83 or 84. So A and B are our parameters, and down here we have A and B. So we're just going to substitute them in. So what that looks like is over here. So I can say, hey, y equals, my A value is 2.09. 5 doesn't really say what to round it to, so I'm going to do 2.1. And then I'm going to put parentheses in for B. The value is 1.422, so I'm going to just do 1.4. And then I'm going to raise that to the X. So that's our regression model. Alrighty. And that's one thing you're going to have to do tomorrow on your classwork. So for number 2, we have another table. So we got our table that represents the population of Newton since 1995. And so we're going to basically just do the same thing over again. I'm going to select table. Please, when you're doing this, make sure that it still says X1, Y1, because sometimes if it pops up like a different table, like if I wanted to go here and maybe hit a table here, it would say X2, Y2, and then it kind of messes up your equation. So, but mine still says X1, Y1, so that's perfect. So I'm going to do 0 through 6. So 0, 1, 2, 3, 4, 5, 6. If you're going in order, Desmos will fill that in for you, which is kind of nice. Alrighty, 247, 372, 550, 884 maybe. Nope, 842. 1221. And see there, it's real easy to accidentally have an extra number in there, that 1915. And then 2786. And then on the second line, I'm going to do the same exact thing that I had done. Y1 is similar to A times B. Raise that to the X1, and it'll give us our parameters here. Again, just make sure you hit log mode. And so my A value here is now 246.92, and then my B value is 1.499. So, okay, 246.9. So my model here is going to be y equals 246.9 times 1.49. I'm going to round that to 1.5 to the x. That should be a parentheses. Alrighty, now we need to figure out what is the population approximately going to be in 2003. So your x value is the years since 1995. So we need to figure out how many years since 1995 is 2003. So I'm going to go back over here and just do 2003 minus 1995, and that gives me 8 years. So when I substitute into my equation, I'm going to substitute in. I'm going to rewrite it to, and then instead of the x, I'm going to do an 8, and I'm going to use my calculator to help me evaluate that. Raise that to the 8th power. And so approximately in 2003, it's going to be 6,327.77, 6327. And since it's 7, we'll just do 0.8. Technically, population should be whole numbers, but that's okay. All righty. Example 3. Here we go. So here again, another one where we're just looking for the model. So we got the numbers 0 to 5 here in my x value. So I'm just going to take off. I'm going to go back and use my old table here and just take off 6. And I'm just going to redo my y values. So I've got 10,000. And then 8901. 3. 0. 2087. And 739. Alrighty, so what should have happened is this was adjusting for us as we went along. And so now we still have, so we have a different A value and a different B value. If you notice, our B value is now smaller than 1, or between 0 and 1, I should say. So, which makes sense because our data is going down. So 14,577.9. So my model is going to be equal to y equals 14. Oops, why is it doing that a little bit? 577.9 times 0.6. We'll just say 0.6 and raise it to the x power. And there you go. So if it's looking just for the regression model, we just need the equation. And sometimes it'll say, hey, what's the regression model? And we need to use it. Okay, last example. So we're going from 0 to 5 again. So I'm going to just change up my y values here. And don't worry about the error that you have underneath. It's just, it has that error because we don't have any data into y1. Okay, so 4, 6, 5, 2. Five, 4, 0. 6, 7, 8, 8. And then last but not least, 13,400. Okay, so here we go. My parameters. So I'm just going to take those and substitute them in. So 4, 5, 7, 0, 7, 9, 9. And then 1 point, we'll round that to, and then raise it to the x. Tablet's not working so well today. Let me try that a little bit better here. (1.23) to the x. Alrighty, and then so what's our population going to be in 2020? Okay, so we need to figure out how many years since 2010 is 2020. From 10 to 20, it's just going to be 10 years. So I'm going to substitute 10 in for x. Alrighty. So I'm just going to get 5, 0, 4, 5, 0. Raise that to the 10th power, and that gives me 35730.1 or 0.08. So it's going to be 35730. .1. So that's how we do our regression in Desmos for exponential functions. Again, very similar to our linear regression that we've already done, as well as our quadratic regression that we already have done. So if you have any questions, though, please make sure you message me. And again, a copy of the answers and some extra information will be up in Schoology.